All right, so kind of get started here. During the recording, kind of have what you guys are saying. Okay. So we kind of left off with this example. I walked through it with you in Excel. How we not only calculate means and variances, but how we're going to calculate them when different outcomes have different probabilities. So just some kind of housekeeping stuff before we kind of jump into anything today. So we don't have any kind of current assignments. Everything we're just kind of working on kind of with these files from module 1. Next week, we'll start having these in-class quizzes. So this is where you need to somehow be able to access Canvas in class, whether that's your phone or whatever device that you're bringing. What I'll end up doing is I kind of open them up. I set the time. They'll be available for the next 5 to 10 minutes. I'll give you guys time to work on them. I'll give you an access code to get into them. And then after that time, kind of make sure I'll kind of give you like a minute reminder, make sure you're getting your answers submitted now. We'll then often review those questions. Sometimes I'll be kind and we'll go through them together. All right, so as long as you're in class, getting that access code, they should be like relatively easy points. Like a lot of times we'll work through them together. So after class today, I'm not 100%. I think you can find these on the files tab. In fact, right now I'll just kind of make those available. I've got kind of the first set of practice problems up there. We don't have the first quiz until after next week. But if you want to start looking through those problems, what is it going to look like in terms of the stuff that we've covered this week? That'll be something you can kind of start doing. Now, I think I got some questions last class. We're going to be doing a lot of work in Stata today. And the only thing that you will ever see on the quizzes from Stata is not how do you code something, but actual output that we're getting. There won't be as much of that on this first quiz as there will be in subsequent quizzes. So, any other questions for me before we kind of dive into material? Okay. All right. So, kind of left off thinking about how we calculate those means and variances. Someone asked me, reached out. I'll upload after class today the class work that we did in terms of the Excel file, where you can see exactly how we calculated the mean and the variance of this random variable using those associated probabilities. But to kind of just give you like a generalized example in terms of when we're calculating means and variances, we could do this without probabilities as well, right? I mean, this should be, I hope, relatively easy, but just for me also to get some kind of practice, I don't do this often. All right, but if I had a set of values, so let's say, whoops, no, where am I at? Well, see, this is where I need to get myself into the next century. So let's say I've got, I don't know, 2, 4, 6. If I want to find the mean, what do I do? Just add them up and divide by the number of numbers I have. Kept it a really small, simple data set here. I do what? So I get what? 12 divided by 3. So I add these up. I don't want the highlighter. Let's see. Can you see this better? There we go. So 2 plus 4 plus 6, right? All right. So this is where I wish we had a dot cam. I might have to start bringing my own. So I'm not good with this. All right, there we go. So why isn't this working for me? There we go. 2 plus 4 plus 6. I've got 3 numbers, right? So what? This adds up to 12 over 3. I get this mean of 4. Okay? If I wanted to calculate the variance, what do I do? Nope. All right. All I'm going to go through and do is take every single number, right? So 2 minus that mean, and then I need to do what if I'm calculating the variance? I take that deviation from the mean and I do what? Square it, right? So I go, this is -2 squared, to get 4. So the next thing I'm going to do is take the next value, 4 minus the mean. And notice this value is exactly equal to the mean. So this is evidence from one observation that there's no variation in the data from the mean, right? But that's just one out of the three observations. So here, I end up with 0. I then go to kind of the next value. I subtract the mean. Now notice when I have something that deviates from the mean, right, by a value of 2, well, 2 squared is still 4. So when we're calculating a variance, anytime I square something, negative or positive values become positive, right? So to get the variance, I would then add these values up. So what? These add up to 12. I then divide by the number of numbers I have, which is 3. So I have kind of a weird example here. I accidentally hit something with my hand, so this is why I don't typically use this. All right, and we get a variance of 4. Right? Just happens to work out they have the kind of same value here. Yeah. Oh, sorry, it's not 12. This is 8. Right? So that works out to be what? 2.66 repeated. Sorry. I looked at my numbers wrong there. Kind of doing this just on the fly to give you a kind of quick, easy example. So the point I wanted to look at here is if we have deviations from the mean, with our variance, we don't care which direction it is, right? We just care that it deviates from that mean, right? That is one observation that is evidence that our data set, that observation was however far away it was from the mean. Now, what happens when values become further from the mean? So let's say, just assume for a second I had the same mean value. Let's say I added like another value of 8 in. Well, notice when I have 8, it's 4 away. But when I square that, it becomes a much larger value, right? So we really over-penalize values that deviate a lot from the mean, okay? That's what our variance tries to capture. I think I said this last class. If I have the variance, how do I find the standard deviation? Simply take the square root. And so hopefully this is a lot of review from kind of your review of statistics. This is why I call it review of statistics, because it should be a review of what you learn in your statistics class. Okay. So with this idea in mind, right, we kind of walk through how this looks differently when I have probabilities associated with this. So some other things that we're going to look into before we jump into Stata here today is I also have different measures of what my distribution looks like for a specific variable. So the variance kind of tells me how much it varies from this middle point, but I can have distributions that look something like this. So they're not kind of nice and easy. So a symmetrical distribution, you might remember this from what do you sometimes just call this? It's kind of nice and symmetrical. It is a normal distribution, potentially a student t distribution, right? So this is, I draw a lot of these because we're eventually going to start normalizing all of our variables to be a standard normal distribution. But if it wasn't, right, if it has like a longer tail, in the first case, a longer right tail, well, what's that going to do? It means that these extremely high values, they're really far from the mean. So when we square that, it becomes a really large value that gets added into our calculation for the variance. Right? So what is that going to do to our mean? It's going to, I talked about the variance. Same idea with the mean, right? When I add it in, it's a really large value. What's that going to do to my mean? It's going to pull it way to the right or increase it a lot. So this is like the example if I was looking at average income of individuals. Well, if Mark Zuckerberg ends up in my data set, it's going to really, give me an incorrect mean, or I shouldn't say incorrect, but it's really going to influence my mean a lot, right? So if that's ever the case, you have these extremely high values, that's going to pull your mean to the right. When we have a median, we said, how do we kind of think about a median value? So, this is where I need to start. So if I'm thinking about finding a median value, let's say I've got, I don't know, 1, 2, 3, 4, 5. How do I find the median? I just start crossing off the highest and the lowest value. So highest and lowest value, next highest, next lowest value. Once I'm left with one value in the middle, that's my median, right? So when I'm looking at median values, right? Let's say I have something that looks like this. Well, what's that going to do to my mean? When I add these numbers up and divide by 5 now, my mean is going to be a lot larger. What's true about my median in both cases? Well, if I go through this same process, cross off the highest and the lowest, next highest, next lowest, I still end up with that same median. Right? So my median isn't impacted by these extremely large values, which is sometimes why it's a better measure of where like the central point or the central tendency of my variable is. So these medians aren't impacted as much, which means when I'm looking at a distribution that has extremely high values, it pulls the mean to the right, but it doesn't impact the median as much. Right? So anytime the mean is to the right of my median, we would call this kind of a right or a positive skew. So this relationship of the mean to the median is kind of how we think about skewness. So all skewness means is what's that relationship of the mean to the median? If the mean is to the right or higher, I've got kind of this positive skew. It's pulling my distribution to the right. Right? Or if I think about maybe a nice easy way to remember this, it's your mean minus your median. If that value is positive, you have a positive skew. If I have the opposite, where I take the mean and I subtract the median, and it ends up being negative, I've got negative skew. That means I don't have extremely large values. I have extremely low values. It's a small values. Okay? So it's just another measure that we have the different distribution of variables we're looking at. We kind of start out mean, nothing squared. Squared deviations, that's my variance. Notice here, what am I doing of the deviation from the mean? I am cubing it, right? Why does that matter? Well, if I take 2 squared and negative 2 squared, it's the same value. But if I take 2 to the third, that's what? 2 times 2 times 2, so I know it's like 8 there. But if I have a negative value, when I multiply it by itself that third time, I end up with that negative sign again, right? So there, kind of the direction, how much it deviates from the mean, it matters which direction it deviates from, and that tells me something about whether or not I have a positive or negative skew to my data. We can then kind of keep moving, and I won't make you do calculations on this, but we will kind of eventually, I shouldn't say eventually, we just want to have this in mind that we can take different measures. So we have kurtosis, which is essentially a measure of how fat my tails are. It's kind of closely related to variance, but just mentioning another thing you might have seen in your statistics class. We won't waste a lot of time on this because we're not really going to use this throughout the semester. Primarily, we're not even really going to use a lot of skewness measures. We'll think about skewness in terms of the relationship between the mean and the median. We're primarily going to just be using that mean, the central point of the data, and kind of that variance, how much that variable kind of varies. Another easier way to kind of think about that. So, I was hoping to get through that last class. I didn't, so kind of going through that pretty quickly. Because what I want to spend a lot of time on today is introducing you to that program that we're going to be using throughout the entire semester, kind of to work with actual data. So this is a kind of reminder. Hopefully you've done this after Tuesday, because I said try to make sure you're doing this before the next class. If you haven't, you can watch me. Probably better to get this going so you can start to work along with me. So I said, you want to make sure you had that cloud storage authorized. So that was just searching cloud storage on one.iu, making sure you log in. It's going to ask me to do all of this. This is where I might start. Unfortunately, I can't yet until I talk to the tech people because there's only one USB-C, so I can't use this iPad and my laptop. Hopefully I'll get that resolved so they can put something in here so I can start using both. So you'll go down here once you log in, just make sure you authorize that. I authorize that OneDrive. Once you've done that, you go to IU Anywhere. So again, we walk through this step by step Tuesday as well. You'll go to apps. Mine's kind of pinned to the top, but if you scroll down, everything's alphabetic. So mine's pulled to the top here, but around S, you'll then see Stata. Right? I've favorited it, so it pulls to the top. You then just click on the icon, and it should pull open Stata for you. In fact, I've got it. I thought I had it. I closed it out so I could show you. So if I click here, it starts running down there on the right-hand side. I'm waiting. See it on the other screen. So here it's asking me to permit use. It might ask you to do that in your device. Obviously, you got to give it access to the program, and then kind of starts to pull it open for me. So usually I won't go through this. So this will all already be kind of loaded up in class. We don't have to waste time waiting for it. There it goes, right? So this is like the main interface of the program, right? This is what we're going to start out with. Okay? So I'm going to start to generate some code. and upload data sets to this. But anytime I'm running my code, the result of that code is going to show up here. Now, technically, I can type everything down here in the command box, but I can't save any of that. Well, that's a problem if I ever want to go back, right? So I have some students sometimes, especially in the first problem set, once we get there, they'll type everything into the command box and start to take screenshots. I mean, that's a lot more work than what's, and if I stop and I have to go back, I got to retype everything into my command bar. That's not going to be very efficient. Right? So what we want to be able to do is type in this code and save it. So the way that we're going to have to do that in Stata is there's this little notepad right here. And you notice when I kind of go down, it says, do file editor. A do file is where you can type your code in and then it calls it execute or run it. And then you can save a do file, right? So I'm going to go ahead. I could start a new one. I've got two screens, so just popping it up over there. This is what the do file editor looks like. I can start to type a bunch of code in here. And now this, I can go and save, and I can then reopen it later. So if I did this and I saved it as whatever I wanted to call it, so I don't want to save that one, I then would just go to File. Now I can open up data sets from the interface. I can also just open up my do files, right? So here I'm going to go to File, Open. Now, because I have my cloud storage linked, wherever, this is going to be annoying. So wherever I've got my, I can go to this PC here, go to access my OneDrive. I've got all my files. Everything's kind of sorted here. What I would suggest, especially once we start using data, just create a folder on your OneDrive where you throw all of the data sets that I give you on Canvas into that folder. I'll show you, I think after we go through some stuff later on today, that'll make sense as to why, but that's what I would start doing. If you want to break it down week by week, you can, but I'll mention here in a little bit why that might be a bit troublesome, especially early on when we're not quite familiar with how we work with Stata. So create a folder to start throwing everything in that folder. So I've got week one, excuse me. Here's a do file I already saved, right? So when I had that do file editor, I typed in my code and went to File, Save As. It saves it as essentially, it's just a bunch of text, right? So that's a do file. So notice next to it, it'll say like type. Depending on your device, it might have next to it like the, what do you call that? Like the file extension, right? So like a Word document is .docx. The do files are .do. That's a do file. Okay. So I'm going to go ahead and open that up. It then pulls open all this code, right, that I've already typed in and saved. Okay. So you'll put all of your commands or your code into this do file. You can then save that and go back to it later. If you type it in that command box and close out Stata, it goes away. Okay. Is that questions on that idea? So we've currently got two windows. The program where I'll see my output, and then my do file where I can save my code. So the next thing I'm going to want to do is, well, I want to code some things up. Maybe I can find the mean, find the median of different variables in a data set. Well, I need to have a data set, right? So how do I open up a data set? Well, for right now, I'm going to show you some different types. Once we get later on in the semester, I will give you these data sets, and they will always be in Stata format. Right? Now, you can import Excel files. We'll see here in a second, I can import CSV files, which if you haven't used those, know what that is. It's just an Excel file that can like store more data, basically. I can import other types of data sets as well that aren't in this kind of Stata format. Once again, really after this first week, I'll be giving you them in Stata format. So here, I'm going to go, I've got the code, but this is going to look different for everyone's device, right? So this code says to import this CSV file, but it's pulling it from where? My iDrive or my OneDrive, and then all of these different folders. This is why I said just get one folder and throw all the data sets in there, because every single assignment, every single class, you don't want to have to like change what we call the file path extension, right? That I have to like update where this file is in. If I just always throw them in the same folder every single week, you can just open up these data sets from the same folder. Okay. So I could go to kind of import this. I could run this code. But I just want to kind of show you, even if I didn't have this do file, and maybe an easier way to start out, and you can always copy and paste things from the output to your do file. Stata is a pretty nice interface that like I don't have to memorize and know all of this code. So if I go here and I go to File, and then down here, I'm going to import something because I don't have it. I have it as CSV file. It's not in Stata format yet. So I have all these different options of files I can open. So, whoa, I've got a CSV file. I believe if you go to Canvas, it's that state cigarette tax file is what we're going to try to open. So I go to kind of open up this CSV file. I click on this folder, and I need to find it. All right, well, here it automatically pulled it up for me. Well, here I go to my OneDrive. I've got it in this folder, in this folder, in this folder. There it is. So when I hit open here, what it'll first do is it kind of gives me a preview of what this data is going to look like once it imports it into Stata. So I've got a bunch of different variables. I've got states, years, cost per pack of cigarettes, taxes per pack of cigarettes, et cetera, et cetera. So I've got several variables in this data set, and I'm kind of importing it or bringing it into this Stata program. Okay. If you need me to slow down at all, or you have a question on a step, make sure you're asking, because I want to make sure we're kind of getting off to like a really good understanding so that as we move through the semester, a lot of this stuff becomes kind of old hat. Any questions up to this point? Okay. So if I'm importing these files, I haven't actually opened up the data yet. It's just giving me a preview. So I'm going to go down here, hit OK, and it'll actually kind of convert this CSV file into a data file in the format of Stata. So I'll hit OK here. And just to kind of make sure we're seeing this, this was under week 1. This was one of the Stata files I gave you that we were going to start using. So we kind of practice opening this up on our device. So this is where having something in front of you, a laptop, where you can kind of work along with me. So then when you get back, to your apartment or whatever, and you try to do this and you can't get it to work, you can ask me questions in class. Okay. So is anybody having any issues here right now? Yeah. Your connection. So what error is it giving you?
It's just, it says connection established before.
Connection to what? Like, can you get Stata open?
No, it's not like
I can't get it open either. I just get a blank screen.
Yeah, so that was where we kind of talked about last class. I need to make sure that Citrix workspace is kind of downloaded to my device. So let's see if I can remember off my head where this is at. So I believe if we go to, well, what it should do is when you try to open this up, is it not prompting you?
No, I can't even get there.
Can't get here?
No.
Okay, so if you can't get here, we might have some deeper issues we need to talk about, because you should always be able to go to IU Anywhere and have all of these programs as a student.
Yeah, when I go to log into IU Anywhere, it just goes to a blank screen.
Is that happening for everyone?
Happening last week's one.
Maybe,
I think it was just the Wi-Fi.
maybe I'll say maybe it's an internet connection issue.
I can figure it out.
I'll hopefully that doesn't persist. If we have internet issues, I'll have to talk to someone in the building. I can't imagine that's the case because everybody up there is using these types of things.
It says, like the internet's also an issue.
For you?
It says connection failure.
Okay, well, it looks like I'm gonna have to talk to a tech person who's in control of the Wi-Fi down here. If we have an internet, so can you access like Google Pages?
Yeah.
Like any other website, like if you pull Canvas up, you can see it.
Yeah.
So my guess is that we're gonna have, if you have internet access, this is potentially the problem. So you can't even get to this interface on IU Anywhere.
I can't, but I'm guessing they.
So if you go to IU Anywhere on one.iu, you can't access it.
I can access it. But
Okay.
The apps.
So when you go to click here, it's not working. So what did I say last class we're also going to have to do? We're going to have to go up here to account settings. Okay. We're going to go down here to tools. You probably didn't get this downloaded. This was that Citrix Workspace app. So the only way I can open up these programs from IU Anywhere is I have to have kind of like this extension enabled on my device. So there's an option to download it for a Windows and a Mac. You'll have to go through and download Citrix here. Okay. Now I've already got it downloaded here, but I think it'll let me walk through the steps for you once again.
So is that like 4 days left?
On what download?
Or I'm trying to like download this.
Citrix?
4 days left.
So this is what, maybe try to do it after or outside of class with a better connection issue. It shouldn't take 4 days.
Yeah.
In fact, that's wild to me. So I don't even know how to explain that. I mean, it's just such a slow internet. I don't know. So I guess maybe try it when you're outside of this building. Make sure you're on, there's what, IU Secure and IU Jerome or something like that. I think the IU Secure one is the one that's going to give you a faster connection. But once you go to download here and you're downloading Citrix, right? And you go to download this file, you know, and I accept. It'll pop up here under downloads. Mine's luckily not taking 4 hours. You'll then kind of run this. Oh, it's not going to let me show you guys this because it's already downloaded on this computer. So if I go back here, is there a way I can? So it shows. Oh, this isn't a Mac. Maybe. Sorry, I'm thinking about my laptop. So I go down here. I'm going to download it for Windows. So then it kind of shows that downloaded program. Click on that. Waiting here. And now kind of see this icon pop up down here. Installation error. I'm getting that because it's already installed on this device. You shouldn't see that prompt. Yeah.
Mine said when I go to open like a file, it says I have a restriction.
So it's data.
Yeah.
So let's hold off on that for a second. Okay. When you're going through this, if you try to, there might have been a point in the process when you were opening up Stata. So maybe try again. I don't know if it was on the screen or if it was on my other screen, but it will ask you like to permit use or block use. You'll have to click permit, right? All access to your device. Yep. Any other questions or issues people are into? So can people get to the Citrix option and then get it downloaded? Now, if you go to IU Anywhere and you try to open Stata, are you able to get it?
It's still.
Oh, okay. Apparently there might be some Wi-Fi issues. So hopefully once we get this downloaded once, we won't have to kind of have this problem of waiting too long.
Could you just run through again?
The Citrix one?
Just like while you were.
We'll go back to Stata. We'll go back to that. I'm just trying to make sure we can actually open Stata first, right? That's kind of the first step. So if it is kind of being slow here in class today, that's why I went through it on Tuesday and said try to do it before Thursday because I don't know how many people in this area are currently on it. It might be a little bit slow in terms of downloading these programs. Okay. Any other issues or problems here? So we're kind of do some troubleshooting here. Like I said, make sure we're kind of getting this working. So if you're waiting on it to download, also the people have problems downloading the 4-hour one. Is that an actual computer?
Yeah.
Okay. I was gonna say if you try to just get an iPad or something, it might have some additional issues. Okay. So once we get Citrix kind of working, have that cloud storage authorized, I'm able to get Stata opened on IU Anywhere. What I would then do is come back here. Now I showed you how to kind of import that. So was that the next, who was asking that question? So did you go to file import?
I just kind of missed it because I was just doing it off and then by the time
Okay.
I did that.
So if I have the program open, I want to import a CSV file. So I went down here to file, import that CSV. All right. If I'm doing that, I then find where that exists on my device. I kind of already walked through the steps to get to the folder that I moved that file to. Once again, right on my OneDrive, I would just create a folder that's ECON 371 and just start throwing all those files from Canvas into that folder. And this will make, I think, sense here in a second. So I imported that. Now what it did, I don't have to run this twice. What that did is it gave me the code it was actually using to import that file. So what I would do is then look at this. Now, there's kind of a problem because I'm trying to show you a bunch of things at once. If I make this larger, it won't truncate this. So notice here, like it should have all been on one line. But because I'm having this to be a little more narrow. If it doesn't have enough space, it'll kind of move that down to the next line and show you this like little caret, right? To let you know this is really all one line of code. And it always puts this kind of decimal sign or kind of period out front. So, you know, whatever Mac you're on, I'm going to kind of talk in Windows, I control C this or I copy this. I would then go my do file editor. Just paste, hold on. There we go. I just have to press these buttons a little bit harder, I guess, in this keyboard. So I have to kind of get rid of that space, right? Because it like put it on separate lines because it didn't have enough area. Is that clear why I had to do that? If I had this like pulled way open, let's say I go do the same thing. I import that CSV file. And this will allow me to show you two things at once. So it's going to have a problem. It's going to ask me, do I want to continue and replace the data that's already there? Right? I'm going to say yes. Right? So notice, what did it do here? Well, the window was big enough, so it gave me all that code on one line. Right? So, you know, try to have the window open and, you know, your full screen if you can, because then you don't have to like worry about deleting that when you copy and paste it over. Now, notice it also it's slightly different than what I had before. It threw on this extra term of comma clear. So when I had existing data and I wanted to open up another data set, I had to tell it to clear out the existing data. Now, you don't have to worry about this if you're not typing it out and you're using that interface. It kind of gives you what that code would be. Okay. So that's our kind of importing a file if it's in CSV format. Once again, I can copy this. I'm going to make this low again so we can see everything. I then go to my other window, which was that do file editor. I then just kind of paste that code so I don't have to go through this process every time. Because now if I want to do this, so this was that second code where I had the clear command. Instead of going back here and going to file, import CSV, once I have that code, if I save that in my do file editor, close out everything, came back to it later, if I highlight that code, and then there's just like this little play button up here, it says execute, it takes that code and it runs it in the program. So I have it selected, I hit execute. Well, what didn't it like here? Oh, okay. Well, the problem is I changed my file path. Right? This was the one I had saved prior to class, but I had it in a different folder. So if you were to look closely at what that folder, that file path is, the one that I just ran in class, right? I had week 1 materials. I had different subfolders. So this is where it can get tricky, which is why I probably don't want to start to throw things in all these additional folders, because then my file path is always going to change. Right? I'll show you kind of a workaround around that here in a second. But for now, I would just try to keep that file path. Always throw your files in the same folder so that you don't have to kind of worry about this issue. If you move them later on and they're in a different folder, well, this code won't work, because this is telling Stata, this is the folder set that this file exists in. Well, it's not there anymore because I changed how I had my folder structure. That's a problem. Okay. So what I can do is say, okay, look, I know that this is wrong. Right? I know that it's in a different folder now. So what I'm going to do here is just show you one trick. Is so I want to do global path. I'm going to start kind of these parentheses. So let's say I take this file path. That's the one that it's going to open up here from this device from my OneDrive. So I'm going to copy this and then paste it right here. And this is, we'll see if my coding memory, I do a lot of this, not always from memory. So if instead I get rid of that old file path, and this is what I actually will typically do every week, I will start the file out with setting, it'll kind of have this at the very beginning of the file, because if you try to execute my code, mine's gonna look differently than my folders will look different than yours. So instead of kind of having this line by line, if you have this global path here, and then you kind of run this, so let's see if I remember right. No, it's only $1 sign. So whatever I've set as that global, that word path, it's going to then input this right here. So if I run that line of code now, that global, and then I import that same file, but it now knows it needs to pull it from this location, which how did I know that's the location? It's, I don't want to have to look and then kind of, I think if I open up in Finder or open up it in the little folder there, I can see it. But if I just manually import it, it tells me, right? It gave me the code for where that file existed. Yeah.
Are we supposed to have all this code up in a do file right now?
I mean, this do file's on Canvas, right? So if we go to Canvas here, I've got that do file up there. So you would download that. If you wanted to open that do file, remember I said, you go to the main program, how did I originally open that? I just went to File, Open, right? Now later on, there's something else we can do with this, but for right now, all I've shown you is when you go to Open, there are some data sets I can open. That's something slightly different. We're going to hold off on that for a second. But this is where I can open those do files if I've downloaded and saved them from Canvas. Okay. Any other questions up to this point? Yeah.
So I down the workspace and so.
Stata won't open for it. Is it giving you an error?
Just content your system.
So it's just like failure to launch application. That means something's not quite set right with Citrix on your device. I can try to help you after class and we kind of get things worked out. So if anyone else is having issues, we can talk after class or come by during office hours on Monday and we kind of try to get everything sorted out. It's going to be a little bit different for every device, depending on what the settings you have prior. But that error means that something with Citrix isn't working correctly.
Every time I try and import files from Canvas, it says this operation has been canceled due to restrictions. So if you please contact your system.
So where are you saving those files?
I mean, it's literally just when I open up, like when I click import, I mean, I was just open up my computer files. That's the first thing that pops up right away.
So did you download the file from Canvas?
I did, but like before I could even get close to that file, just that popped up.
So hold on. So if you download the file, do you see it existing in your folder?
Well,
Like-
it's not letting me. Oh, you're saying like on my.
If you were to go to Canvas and you download the slides, you can't preview these programs on Canvas. You can download them. So like if you downloaded the PowerPoint slides, you would then have to, where did it download? It might be in your downloads folder. That's where you would then open up that PowerPoint slides in your personal device from that program. When you download the do file, wherever it downloads, are you going to file and then kind of opening up that do file?
That's a file.
Open. So the import was only to upload the data. To open the do files, you go to simply File, Open, and then you can select those do files. If you have it on your, you can't get it from your device. You have to put it where? What was the whole point of doing the cloud storage step? It has to be on your OneDrive. If it's not on your OneDrive, I think that's the area you'll get. It can't open it up from your personal device. You have to have it on your OneDrive. That you don't have access, it won't, you haven't.
You have restrictions to it?
Yeah, so it might ask, you have to allow it. So I think one of the options, every device is gonna be a little bit different. I think the way it's phrased is you like have to allow it access. There should be an option, just like other apps, where you can then have it set so that it's always, I think it says it's always access. Because otherwise, it's something about the block that exists between your OneDrive and your device, like it doesn't want you to access bank information or something like that. So you have to grant it access to that program access to your computer. So when it gives you those options, if you close it out and open it up, it'll always prompt you with that unless you select the option, which I believe on most devices is phrased as always permit or always allow access to this program. See another hand before that. Okay. So that, look, I know this is gonna be a rough start, right? To kind of get used to this, right? So I know I'm saying things and you're probably trying to frantically kind of go through things and you might kind of miss what I'm saying. For example, you have to have them on your OneDrive. Every device is a little bit different. You might have set some settings that never allow other programs to access. So it might be, might go through your settings to make sure you can permit this program to have access to your computer. Once again, kind of work through some of these things right now after class. If we're not able to kind of get them resolved, or kind of office hours are another good time to do this. Okay. Were you able to get it putting it on your OneDrive?
It's like not working. Since the conversions of zero.
Okay. Well, it looks like I'm definitely going to have to talk to someone about the connection issues in this room, which is frustrating for me, but also for you. So I apologize if that's causing an issue right now. Like I said, I know they redid this room literally the day before we started. We're still working on it. So I'll contact them and try to make sure they've got, Wi-Fi extenders or whatever it is that were needed so that we can all kind of use this program or all use the Wi-Fi simultaneously. When I'm over in like Ballantine and stuff like that, I never have issues, right? They make sure that everything's working well there with so many students, okay? Any other questions or things we're running into here? Okay. So this is where we'll kind of have to walk slow but need to kind of get through some of this. So if there's any other technical issues, we'll try to kind of deal with those after class, or once again, I'll reach out about the Wi-Fi. So where did I leave off? So I was showing you how to open do files. We already did that. Okay. So this is where I might kind of get that error. And I said, it's because that file path. So if I set the global and then I use this kind of $ kind of brackets and I put whatever I call this, I don't have to call this path. I could call it folder or whatever I wanted to call it. This is just the name. When I then go to execute this code, now it opens because I had that file path. Like I manually opened up the file. So I know that this is the correct file path. So every week when I give you these do files, this will be like the first line of code. What you'll put into this path is wherever that file exists on your device, which is why I said create one folder and always put everything in that folder, because then your path, where's it at? There you go. Then that path will never change, right? If you start to put it in different folders every single week, you're going to have to go like, oh yeah, it's no longer just an E371 week 1. Now I got to change to E371 week 2 or in week 3, right? I have to constantly update it. Whereas just for the sake of this class, I mean, obviously like organization wise, it's nice to throw things into subfolders, but because we're not super familiar with kind of setting these globals, if I can get it to work once and I just start throwing everything in that same folder, I know that I can then always open those files from that specific folder. Does that make sense what I'm saying there? Okay. So, but if you don't, like the nice easy way is if I got to go manually through it and import the file, it lets me know where that file exists. Okay. So kind of moving forward here, what else can we do? All right. So I've opened up this data set. In fact, I wanted to show you that this won't always work. So we'll just keep using that same kind of folder path here. So I'm just going to import it again, just to show you that, do different lines here. So I'm going to open that up again. Now what we can start doing here is when I open up that data, there's a third window, right? So the third window is going to be if I come up here, there's these 2 grids, right? One of them is the data editor. One of them is also data editor. This one allows me to edit. This one, I'm just going to look at or browse the data. I would never use the edit option because what that allows you to do is change the data. You should never be changing data. That's the whole reason why we're using it. There's other uses for Stata, which maybe that makes sense. But for us, we want to use the actual recorded data. But we might want to look at it. So I'll go to this browser and then I can see, okay, this is the data set it opened up. This is what it looks like. Here's the different variable names. That'll always be kind of the column headings. And then here's the different observations. All right, so here if I've got different states, I've got them all in 1970. This initially looks like I have a what type of data set? Multiple observations, one point in time. This would be cross-sectional data. Now, gotta be careful. Notice there's a huge scroll bar here. Oh, I've got tons of years. So if I have the same states for multiple years, I actually have a panel data set. Okay. So just kind of some things I mentioned on Tuesday. So this is what my data set looks like. Now I might, sometimes these upload. I was just working on some stuff prior to class today, and this variable was like ft_1_3. I was like, what the hell does this mean, right? It was just named very odd in the original data. So maybe here, I look at one of these variables and like, I don't like the way it's named, right? So I've got my program. I can kind of see what those variable names look like. Now, obviously, like I'll truncate these so I can kind of widen it to see what the full name is. Oh, I might have to start bringing my own mouse. This one is like very wild, very sensitive. So I go back to the do file and I say, okay, look, this variable that's called location ABBR, I mean, I don't know. I might go back to that and forget what it even means without looking at the data and being like, oh, that's the state, right? Or the state abbreviation. So what I can do is I can rename variables, right? So I have this original variable and it's called, and this is where I can kind of show you here. What is it? Location description. Abbreviation. Sorry, I accidentally ran this code already. So let's say I wanted to rename the variable state, which I actually already renamed it. Maybe I want to call this state abbreviation. Okay. This rename command, if I highlight this and then hit execute, right, it will rename that variable for me. Just makes it easier when I'm working with this data set. Okay. Now, one thing when I'm renaming variables, so let's say I tried to take this location description. It's not the abbreviation, it's the state's actual name. So one distinction to make here is when I download a data set, these variables that are in red, what do you notice is different about the ones that are from the variables that are in black? These are all numbers. These are, you guys are well into college right now, right? These are letters, right? So whenever you have text, right, it shows you that's red. You can't do anything. You can't calculate a mean because it's just text. Black is numerical values. We can start to calculate means and standard deviations of those variables. So here, I still want to keep these because I might still be interested in what state it is. So this location DESC, I said, okay, I want to make sure that if people look at this, they know that's just the state name, right? So I'm going to rename that variable. Now, one kind of issue I wanted to show you here was I can't type this out like I would in a sentence. If I try to rename that variable and I have state space name, oh, once again, I'm going to have to bring my own mouse. This thing is, I ran it. Oh, but I can't see the program here. It gives me an error, right? And that's because when I name a variable, there can't be any spaces. So if I do want a space to make my variable names like a little bit easier to read, I have to use, or what I use, I guess you can use whatever symbol makes sense to you, but you have to use kind of this underscore. Now, when I highlight that code and execute it, now it renames the variable, okay? So this is just one thing we can start to do, right? Rename variables. That's fairly nothing too crazy yet. Okay. Now, I opened this up as a CSV file and converted it into Stata. The problem is if I were to close out of this program now, what I had open, that data doesn't get saved. When I renamed the variables or if I started to add variables in, it won't get saved. How do I save an updated data file? Well, once I've made these changes, I've renamed my variables, I'm then going to have to save my data set, not my do file, right? My do file is open right now. I could click save here. I don't want to because I want to keep the original one I uploaded to Canvas, but I could save this do file. That won't save the data. In order to save my data that has these new renamed variables, I have to go to the program, go to File, Save As. This is going to save it as a .dta. When I'm in the program, I'm not saving do files any longer. I'm saving the data that the program has opened. Okay? So the file extension there is not .do, it's .dta. Okay? Now it defaults to that, and all I have to do is name it. So this is like, I don't know, in class state cigarette tax file. Okay? This will save the data with the changes I made, with the renaming of the variables. Okay? So I'll click save there. Now notice, once again, it truncated it because I had it, kind of made smaller. It gives me the code that will do this. So I could copy and paste this over. So, I could go ahead and do that once again. Even when I save things, if I do change my folder paths, once again, it's probably easier to always use whatever I had it defined as. And once I define this global once, I don't have to keep rerunning this code, right? I already ran that global line. It stores it there. So I'm now going to save that state cigarette tax file. It was a CSV before, but I want to save it as a .dta file, right? I want to save it as an actual Stata data file, okay? So if I do that, so I'll show you this first. So let's say I go to save this, right? I execute that code. It's going to save it for me. Great, right? But what if I go back to that data? So once I have it saved, I could then, instead of having to go to import, it's already in the right format. So now if I go to file open, I can open do files, but I can also open this Stata dataset or .dta file that I just saved. So when you go to file open, you can open up the do file. You can also open up the data file, which is the exact same thing we're working. And notice it has those changes that I made to the original one. Okay. Any questions over anything there? You want to see anything again? Yeah.
Could you pull up the global path
Hmm?
again?
So what will be in parentheses for you is when you first opened up or imported that CSV file, this was like the original line of code I had when I did it. Everything prior to that backslash and the name of the file, this is your global, right? So that's what you're going to kind of put into that path, right after path, or in the side of those, not parentheses, quotation marks, right? Any questions? Yeah.
Does the order matter? Does global path always have to come before the?
Yes.
Oh.
The order and everything that we do matters. Everything in our code. Right? You think of code as like a language, right? So if I say I ran away, it's very different than away ran I. Right? It doesn't make any sense if you kind of mix things up. It doesn't make any sense to Stata if you put these things in different order sometimes. Yep. I shouldn't say sometimes, all the time if you put them in the wrong order. So. Any other questions here? So one other thing I wanted to show you is, let's say, okay, I've got this, and I'm like, oh, I got this data set open. It's saved now, but I don't know, maybe I want to rename, I think packs per capita. And I notice here, this is kind of a nice feature. If I start typing a variable name, some of them can be rather long. It tries to auto guess, just like, if you're in Outlook or Exchange, sometimes it'll try to guess the word that you're looking for. And so here I'm like, oh, perfect. I don't have to type this whole variable out. It's packs per capita. Okay? But let's say I want to rename this. I don't know why I would want to do this, because it would make it more difficult to know what it is. But let's say I want to abbreviate it, right? Packs per capita. So I go to kind of rename this, right? Does that for me. I'm using now that Stata data file that I saved. Let's say I want to save this change. So I go back and I say, okay, I want to save this again, right? If I try to run that same code, it gives me an error. Because similar to when I opened up the data set, if I already have a data set open, I had to add what? That comma clear on the end. Same thing when I save it. If I've saved a file, a Stata data file.dta once, in order to write over it, to replace it, I have to kind of save, and instead of .clear, I have to put, or comma clear, I have to put comma replace. Now, when I try to run that, now it works, right? So once I save a file, a data file once, in order to kind of save it as the same name or like rewrite over it, I have to include this comma replace command. Now, I can remember this if I'm copying and pasting code. Now, when I go here, let's say I tried to file save as, and I want to use that same file name. If I do it from the interface, so I don't have to rely on everything like memorizing this code. Now, I'll give you do files that look kind of similar in terms of the syntax and what you'll need for these problem sets. But if I do things from the interface, especially when it comes to like opening, saving, not worrying about file paths, it asks me, do I want to replace? When I click yes, it throws in that comma replace for me, right? So a lot of times the user face, especially early on, can be like a little bit easier to deal with. And I think as we progress through the semester, you'll start to be like, well, I don't want to click, 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 click. And I know I can just copy paste this, right? And I already kind of know what it looks like. And some of this stuff that I had, like I changed it a lot of this for you. All of this code here is just kind of reminding you of like, I need to add clear commands. I need to kind of set these global paths. So I kind of did this a little bit out of order in terms of what we're doing in class, but the actual program that's on Canvas kind of has it kind of separated a little bit. Now you'll notice there's some things in this do file that are green. So anything that you just type in, like this is all code, right? Sometimes it'll be blue. There's reasons why it's blue that don't really necessarily need to dive into. But like this blue, kind of red, black, that's all going to be things as part of code I can execute. Anytime you see things that are green here, notice what's in front of all of them. Double backslash, right? If I want to put comments into my do file, and this will be very helpful once we get to that first problem set, because I might ask you to do something in Stata and ask you a follow-up question that like you would need to tell me, I got the mean and the variance from Stata. I can report the values, but what does that tell me? In fact, I could get the mean and the median, and then the follow-up question in the problem set would be, what is the type of skew that it has? So you would give me your code to calculate that mean and median, because when I've got thousands of observations, you're not going to do that by hand, right? But then what I can do is put my answer in. Green essentially means text. It's nothing I can execute. It's not code. It's just a way for me that if someone jumped into my do file, so I have a project going with another professor right now, and we like update it and kind of look at the same file, but I might not know what he changed or what I changed. You can add in so that someone else can kind of follow along with what you're doing. On the problem sets, here's the code that I used to answer the original question, and then the follow-up question that required me to actually, not do something in Stata. I can include this all in my do file by just making it text, right? And that's what that double backslash does. Now, for the first assignment, some of you will kind of feel more comfortable having your own do file with just the code and then writing something in Word. That'll be okay. We'll talk more about that when I put that first problem set up on Canvas. But I wanted to kind of show and kind of mention you that here as we're kind of establishing our knowledge about how to use this program. Any other questions at this point? Okay. So I'm going to come down here. I'm going to run this text. Actually, let's make sure. Do I have I think I might have changed this originally. So I'm going to go back up here. I've already set my global path. So another good way to do this, like I replaced that global path command compared to the one that I had in this do file. So I'm just going to get rid of that because I've already set what that path is. So I'm going to open up that data set again. Notice it has the comma clear, gets rid of my old data where I was renaming things, and then opens up kind of the original one. So let's say I open this up here. I've got my data file open. I could go to the browser. I can kind of see it, right? So here, I'm going to scroll down. Oh, did I save over it? Hopefully not. Did I rename that? Yeah, I did. Okay. Well, easy enough, right? So I accidentally saved over the old file. I don't want this to be PPC. I want this to actually be the original name. So I can kind of type that in. run that real quick, just so it was the original data that I had here. I accidentally overwrote it as I was showing you how to do things. So I've got that original data now, and I kind of made sure the name was the same as the file that you downloaded. Right? So what I can start to do here is also think about, maybe I have these really large data sets, but maybe I'm only interested in, so I've got a panel data set here. How could I make this cross-sectional? Or if I'm only interested at one point in time, I would only keep the observations that came from that time period I'm interested in. So here I just wanted to look at observations that came from the year 2000. Now, generally, we wouldn't want to run these commands. We generally want to keep our entire data set. But if I'm interested on like focusing on just one specific year, I might want to take the original data set and create a new one, right? So here, if we use this keep command, that says only keep the data. And then when we use these if commands, which we'll start using a lot this semester, in fact, next class, I'll kind of show you how we look at conditional means, right? Or conditional distributions. So we're conditioning on a certain statement being true. I only want to keep the observations if that year variable is equal to 2000. So I only want the 2000 observations, like the year 2000, right? Now, I put here a double equal sign. Anytime we use these conditional commands, you can use the greater than sign for greater, less than sign for less than. If you want a conditional statement to be this is equal to this, the syntax, I don't know why this is, but the code is two equal signs. I'm sure there's something on the back end that I don't understand, as I'm not like a software, engineer. But the syntax is always going to be, if you want it to be equal, you have to put two equal signs. Okay. So here I'm going to keep only the observations that came from the year 2000. I'm going to run that code. I now can look at the data, make sure the code ran correctly. Yep, I only have the states from the year 2000. Those are the only observations I kept. Okay. So just kind of another command that we might start using, and more so a way for me to introduce you to, we can use these conditional statements. Now, a very basic kind of command that we have, just to get an idea about what a certain variable looks like. I might act here, I'm interested in state taxes, state cigarette taxes. So I have a variable that's called state tax. That's my state cigarette tax. And I want to know kind of what the average is across all of these different observations, all of these different states. Well, I don't want to calculate this by hand. I don't want to add up 50 numbers and divide by 50 here. In fact, maybe DC is in here, so maybe 51. I should be a little more accurate, right? I can use this sum command, right? Which I can find any of these commands. Typically, they're going to be somewhere on my interface. So I could go like here to statistics, summary tables and descriptions, summary and descriptive statistics. I might want to look at the means. What variables do I want to look at the mean of? My state tax variable. I hit OK. I wait. It shows me what the mean, the standard error, or this is kind of, we haven't dove into this. This is, for now, let's just think about the mean. The other stuff is going to be thinking we have a sample size and it's going to calculate confidence intervals. For right now, we just wanted to look at the mean. Well, I can do all that from the interface, but I'm also in class always going to show you what the code is that would give you that mean, right? So you always have kind of a sample do file for once you start to try to do this in your own problem set, your own work. So here, if I just use that simple sum command, right? Here, it was only the mean, right? The sum command is actually going to give me not only the mean, but a lot of other statistics. So if I kind of execute this, now notice if I highlight this whole row, anything that is in green or anything that I've identified I just want to be text, if I execute that, it doesn't do anything, right? So I highlighted my code, I highlighted that text. It'll show me what that text was, but it doesn't impact the fact that it can run this code. So here I not only have the mean, I have the standard deviation, I have the minimum, the maximum, and the number of observations I have for that state tax variable. So produces those statistics very quick. I mean, you can already hopefully see this is a huge time saver. If I had to do this by hand, it would take me forever, right? Well, maybe not forever. I have 51 observations, but if I had there's data sets with millions of observations, right? So, and I'm not being hyperbolic there, right? They're literally like data sets across time where if you had enough data, you could have a wild amount of observations. Right? So that's just kind of a nice, easy way where we can now get these descriptive statistics very, very quickly. Now, what I could also do is there's another one, which is just comma detail. This will actually give me those measures that I mentioned before we jumped into Stata here. So if I use sum state tax, that's the variable I want to look at the summary statistics for, but I put comma detail, it not only gives me the mean standard, it tells me skewness, it tells me the kurtosis, and it also kind of gives me an idea about what that distribution initially is looking like, right? What would the 50th, so you might not remember exactly from your statistics course, but the 50th percentile is another word for what? So the 50th percentile means there's 50% of the observations to the left, 50% to the right. So if I was crossing off the highest and the lowest, that 50th percentile is the median, right? So I now know my median, I now know my mean. Notice here, my mean is greater than my median. So that means I must have some very large values, right? Or if the difference between the mean and the median is positive, I have positive skew. Well, lo and behold, what's the sign of my skewness measure? Positive, right? So it's going to calculate all these things for me, and hopefully they're, lining up with what we've already talked about in terms of like, I guess call it model, or what the kind of theories, the statistical equations that we have would suggest. Any other questions here? So just a couple more things. We'll kind of dive in here. I want to make sure we get through this here today. So I already kind of discussed renaming variables. Now you'll notice when I use this sum command, what did I say about everything that is here? Can I save that? Let's just state output. It allows me to see it while the program is open, but when I close it out, it goes away. Right? So eventually we would kind of progress to, you can create and save tables from state output. We won't dive too much into that in this class. Primarily like whatever values it gives you, that's kind of, then you can then answer the question, right? So you don't have to present to me the output you're seeing. You don't have to save it. You're answering a question. You just have to get those to, like I asked you for the mean and the standard deviation in a problem. You don't have to give me the output. You just have to give me the code, and then hopefully you've interpreted the output correctly to identify what those answers are. Here's my mean, here's my standard deviation, or here's my mean, here's my median. So, it's kind of a problem. I might want to know what the mean is. What I can actually also do is there's different commands where I can calculate statistics and store them as variables, right? So this may seem kind of goofy as we're first starting out. Eventually, we'll kind of think about, well, using that mean function, it won't always give the same value. In this case, it will. So here, my next line of code, and I kind of tell you what it does. This should create a variable that is equal to the mean of that state cigarette tax variable. Okay? So whenever we're using this kind of EGEN command, what that's telling Stata is to generate a new variable. I want to call it state tax mean. That's what I named it. You could name it whatever you want. Okay? And I want the values of this variable for every observation to be equal to the mean of this other variable, which is the original state tax. So what this will do is it says there's this built-in function. Notice it makes it blue here. I guess I highlighted it, so maybe it's harder to see. But that means use a pre-programmed function that's in Stata. That's how do I use that? I have to use that EGEN command. So what that is saying is it's generate a new variable. In fact, I think I can type out eGenerate, and it does the same thing. There's just shorthands. So EGEN state tax mean, that's the new variable I'm creating. And I want the values of that variable to simply be the mean of that original state tax variable. So hopefully if I do this, I get that same mean of 0.148. So I'm going to run this code. Now notice here, it shows me the code, but it doesn't give me any output. Certain commands in Stata will just give you output here in the interface. Other commands like this are altering the data set. So here, when I go to browse or view that data, what do I now have? I've got a new variable that wasn't in my original data set, and it's simply that mean value of the state cigarette tax. Okay. So I can create new variables based off of the existing ones and add them to my data set. Okay. You know, maybe I have like a data set where I've got revenues and I've got, you know, costs. I could then create a new variable where I calculate profits. Right? Something as simple as that. And then some other commands, not too crazy here. And this is just we're getting used to, you know, I'll have this a sample kind of do file. You can kind of look at what that code is. You can find them somewhere on the interface, to be completely honest. I'm so used to coding at this point. And, you know, you notice when I went to the interface to try to do these things like find the mean, I mean, I don't know. There's like, or is it statistics? I mean, look at all these options. Like, it might be kind of hard to find exactly what I want. Now, what goes a long way is probably Google searching, right? Now, I've had people in the past that try to use AI to do a lot of this work for them. I'll tell you right now, it can be a helpful tool, but it also gets things wrong. Actually, especially as we progress in the semester, it does some really egregious coding errors in Stata. And so Google search is a good way if I can't remember the command to kind of find what that syntax is. Sometimes chat will tell you something and for whatever reason, it's just not right? Different versions of Stata are slightly different and it's just kind of hard to go through the whole thing or sort through it all. So the other thing I want to show here is we can create other variables. So here I'm pulling from this like bank of pre-programmed formulas. EGen, what I want to call this variable, I want to call it the state tax median, and I wanted to find the median of my state tax. Here, I want to find the standard deviation. There, the shorthand there is it's just SD, right? So what I can do here is create these two new variables. So I'm going to run this code. Now, one thing I'll show you, let's say I tried to run all this at the same time. Gives me an error. Oh, I already created that variable, right? I can't create it again. The only one I really wanted to run was these ones, right? I wanted to calculate the median, the standard deviation. So I run that, I go to look at the data again. And now I not only have a variable that tells me the mean, but a variable that tells me median and a variable that tells me the standard deviation. Now, hopefully, when I created these new variables, if the pre-programmed functions were right, it gave me the same values as that summarize command. And sure enough, if we kind of look at these values, those are the ones that I see here in these three new variables I created. Now, once again, right now, you might be like, well, why did I have to do this for every single variable? Probably don't. This is maybe a quick way to kind of get an idea what that value is. And then later on the semester, we'll start to see for different observations. Maybe I could calculate the mean state tax of only states in the Southwest or only states in the Northeast, right? I can kind of start to throw in some of those conditional statements so that this variable is actually calculating means depending on what region of the country that state was in. But for now, I'm just showing you that mean function and how we can use it. So this is typically what we'll do. We'll talk about these statistics. We might work through some examples by hand, or like in Excel, we just kind of go through the concepts. I'll then show you how we can get these statistics or how we apply those concepts in Stata. I get that this is a lot. I know this is a lot at first. It's going to take us some time. I'm aware of that. If you did have issues here today, whatever reason, it's taking 4 hours to download something, which once again, I'll reach out to someone about why there's Wi-Fi connection issues in here. That's where send me an email if you still can't get something to work. A lot of the times, if you send me an email, screenshots help. I'm not just describing the errors that you're seeing. You got some kind of try to go through some quick stuff after class, or Monday during my office hours would be a good time to stop by to get any of these technical issues ironed out before we really start diving into things on Tuesday next class. Okay, so for you guys, you're in a class lucked out. Don't have any assignments or anything this weekend. So a fun, safe weekend, and I'll see you guys on Tuesday.
I have a quick question.
Yeah.
Um,